All right, we're going to be doing another example of function composition given these same 6 equations as example 1. Let's get right to it. It says simplify f of g of x. Now remember, this can be written as fog of x, or if you really want to read it technically, f of g of x. But this spells it out more clearly, f of g of x. So what are we going to do? Well, we have to simplify, right? It doesn't say necessarily to come up with a numeric answer. So we're going to be plugging g of x into the x value for f of x. So let's see how that looks. Well, f of x is just square root of 2x. So wherever there's an x in f of x equals square root of 2x, I'm going to be replacing that with g of x because I'm trying to figure out f of g of x. So that's exactly what that means. And then now we can look and see that g of x is equal to 8x squared. So now we're going to replace g of x, and again I should use more arrows, I know. G of x is equal to 8x squared. We're going to replace that, and then we can just simplify using algebra. 2 times 8 is 16, we still have the x squared, but what's the square root of 16? It's 4. What's the square root of x squared? It's x. Therefore, final answer, folks, f of g of x is equal to 4x. It's really that simple. And what did we actually do? We did what's in parentheses first, which is function composition, by replacing the x with the g of x. And then we did parentheses again by replacing that with 8x squared. And then technically, whenever you work inside of a function, it's considered part of doing what's in parentheses. And then we did an exponent because the square root is the same as the power to the 1/2. We end up with 4x. Love this problem, folks. If you have any other questions about this function composition problem given the equation, let me know.